So I have already launched the QGIS application in my laptop. So you can see here, yeah, the main dialog window of the QGIS application. So as Stefano told before, here you should have a button with the PLANHEAT plugin ready to be launched. So after the procedure that Stefano explained before, installation of the plugin, this button allows you to launch the application. So I click on it. Okay, and the dialog windows magically appears. So Stefano has already commented and shown you more or less all these functionalities. What I have already done before is I have imported a project where the district mapping module and the supply mapping module have been already running. And so all the information that are useful for the district planning and simulation modules are already uploaded by importing this project. So I can directly go to the district planning and simulation module here by clicking on this button. So another dialog window appears in which I am obliged, of course, at this moment, because it's the first time that I run the DPM. I am obliged to select the district planning module, and so the step 0 starts. So I push on the button, and now I have the possibility to load the file from mapping module, district mapping modules, and the supply mapping module. So again, I am obliged to push on load files from mapping, and in this first dialog windows, the information of the building included in the shapefile from the DMM previously calculated appears here. So as you can see, there are a number of buildings that in this case are 28 or 29 buildings. Each of them in the columns are reported all the information coming from the district mapping module in terms of heating demand, the peak value for the heat demand of this building, and the specific heat demand, and then the cool demand, the domestic hot water demand, and the peak power for the three services that we are considering, so heating, cooling, and domestic water. The use of the building, if it's residential or if it is belongs to the tertiary sector category, and the gross floor area of the building. And this is done for the baseline scenario and for the future scenario as well. Then from the attribute table, I have to move to the district tab, and the district tab I have to push the button on source availability. What this button does, it matches the information from the supply mapping module with the information with the information of the district that we are considering. And so now in this moment you can see all zeros, because in the supply mapping model we have only we have imported information from supply mapping module but we haven't launched it properly. So there are no information regarding in this particular use case regarding the available sources in the area. Okay, so once this is done, I can go to the next step and start with step 1 with the baseline scenario definition. As you can see here, we have different shapefiles on the left-hand side window. You can see all the layers that are uploaded in this dialog window. So there is the layer of all the streets in the surroundings of the district that I am considering. In this case, this is the city of Antwerp, and this is a district, a particular district, a group of buildings of 29 buildings in the city center. And so we have so the streets that are coming from the information retrieved by OpenStreetMap, and this information, this layer is useful for mainly for creating and evaluating district utility. Then we have this is the shapefile. Then we have the shapefile for the future scenario and the baseline scenario. So the information coming from the DMM that Stefano shown you before are now here in terms of building, and for each building we can retrieve the information. Okay, there are I don't know if you are useful with the capabilities of the GIS, but okay, when it's not so difficult, and when you start to use it, you can find here many buttons that allow you to retrieve all the information by clicking on the then you have the shapefile coming from the SMM, as I explained it to you before. Here you have the raster layers. Now it's all red because, as I said before, the supply mapping module didn't provide any valuable number. Here are all zeros, and so we don't have any information from supply mapping module, but we can do it and so okay. Now I can. We are in the step 1, that is baseline scenario definition. So as Stefano said before, we are going to characterize and to follow the silicon building and characterization. And so I click on single building here in the energy tab, and this allow me the possibility to select also the other tag building characterization. So here you can see on the right hand side what previously was shown in the picture in the screen. I have the list of all the 29 buildings from 0 to 28, and I have the possibility to select the building that I am interested in. And how can I do it? Directly clicking on each of them here in this windows, and I can also select each of them. And when you click on this arrow here on the left, you can see the more important information that you need to characterize them for the baseline scenario definition. That is the peak demand of cooling, heating, and domestic in kilowatt. Okay, so if you are interested also in a particular building, you can go directly into the map You can go directly. And by selecting with this button here, by selecting building by building, okay, this is important to select the appropriate, the proper shape file in which you can do whatever you want here. So I can select here one building now is in yellow, and you can see that this is the building number 15. So at the same time, I can select more than one building. So in this case, I'm selecting, for example, building 16 and building 16. So by clicking on the buildings on the map, I can select and unselect. Or maybe I can do multiple selection of buildings. And so as you can see, all the buildings in yellow have been highlighted here in the list. There is another feature that allows you to select the building according to another criteria, that is the pick demand criteria. So imagine that you want to select all the buildings that have, for example, here I choose the peak demand related to heating. So anything demand of, I don't know, 30 kilowatt plus minus 5 kilowatt. So I can submit this rule, and automatically but not automatically, because I have to deselect all the buildings and try again. So I want to again understand the sharp buildings with a peak demand of 30 plus minus 5, and only the the building number 15 has this power. So that's why I do it, and to show you that it's going to. So these two buildings have a peak demand between 25 and 35. And so why you have this feature, these possibilities? Because once the buildings are selected, here below you can have the possibility to choose the technology to assign to them. And so since the technology is mainly assigned based on the peak power demand that you are going to cover with the technology, so it is important that if you have multiple selection building, you can select for each of them the same technology with the same capacity of maximum capacity. Because when you have selected this building, once you click on the apply button, the technology is applied automatically to all of them. Okay, so for example, if I try to show you two buildings, to assess two buildings, for example, these two. Okay, so in this case, I'm going to assign the technology for the baseline scenario definition. And so the current situation, this is the reference scenario. The reference scenario against which I will calculate all the KPIs of the scenario. So it is important to know all the characteristic of this scenario in terms of technology. So imagine that we start from a situation in which we have a natural gas boiler for these two buildings. And once you select the different technology, the related their records appears, and so you can easily understand which are the information that you are going to provide to run the simulation and to calculate the KPIs. So again, we will focus only on the heating service, and so I'm selecting here gas boiler for both building number 15 and number 16, and for example, I put here an efficiency of 0.9 and a peak power of, in this case, 30 kilowatt to be sure to cover both of the peak demands of both buildings. And let me put here 0, 10%. So this is something that we have to, let me say, fix better. And then, okay, I can use it, for example, 100 euros per kilowatt for my gas boiler, and the fuel cost of 0.06, and the variable cost of 0.02. Okay, this is all I have to provide as and then clicking on apply, you can see here that another arrow here, and all the information that I have input now appear here. So we have selected the gas boiler as a technology, the source is natural gas, and then here you have the default values, still these numbers are the default values, but they are not taken into account by the calculation. The only information that are needed for the calculation are the ones that you have here in the records, in the fields. Okay, then you have characterized your buildings, and then you can go in this dialog window with supply energy sources, in which you can input the information for each of the 23 sources that are considered in the PLANHEAT tool. You can include all the numbers related to the primary energy factor, the CO2 emission factor, the annual risk, and the emission factor. Now, for simplicity, I put only all the sources. Okay, but if you have the correct number for your country, you have to put here manually these numbers. If you don't have it, it will be possible to retrieve it from the PLANHEAT database. Okay. So I will skip also this part of the transport sector because it's not so ready so far. And so once you have characterized the building and put all the information required, you can confirm the baseline assessment. So are you sure to continue? Yes, quite sure. And so you can go to the step 2 baseline scenario simulation. Here you can simulate your baseline scenario and calculate all the KPIs related to the baseline assessment for the four domains in which KPIs are divided into. And so as you can see here, there are 4 domains that are energy, environmental, social, and economic, and for each of each domain there are different KPIs. So the primary energy consumption baseline, for the baseline, the specific energy consumption, the useful energy demand, so the demand that is coming from the DMM, so what is needed by each of the buildings, and this is what is consumed after the application of the technology, after the utilization of the technology to cover such demand in terms of primary energy consumption. And then there are other KPIs that are related to the utilization of renewables, for example, waste heat, local waste heat, as Stefano commented, and also primary energy consumption from conventional fuels that are natural gas, coal, heating oil, and electricity. Consumption from imported sources, and then other important KPIs related, for example, share of cooling, baseline share of cooling. So how much demand in the baseline scenario is covered in relation to the cooling service by some technology, because it's not the case that all the cooling demand is covered by some technology. So this KPI tell us which is the percentage, and then this thing for the solar thermal penetration, for example, and related to the district heating or cooling network, which is the coverage in the baseline scenario of this network, which are the thermal losses of the distribution system, and which is the linear heat density, again related to the district heating. So for the environmental KPIs, we have about KPIs related to CO2 emission and to so for specific pollutant, NOx, SOx, and so on. For the economical side, for the baseline assessment, we are only calculating the operative costs related, yes, to the operational of the equipment that are applied in the baseline scenario. There are other KPIs related to the social domain, but so far we are not calculating. So if I click here on calculate KPIs, the calculation is running. So depending on the number of buildings, the complexity of the system, the number of technologies, and so on, the calculation can from seconds to many minutes. And so this depends on the complexity of the scenario that you are So now the calculation is over, and we have some numbers here. As Stefano said before, we are still in the process of fixing and debugging, so some results are not so right. We are still making many use cases to fix all the problems, the Python errors, and so on that still are appearing, because we are still in the debugging phase. Running, but in any case, you can see here that some total number, because the total values are the sum of the buildings, the residential building and the tertiary building. So in this case, the two buildings that we have considered are of the tertiary sector. So the primary energy consumption is value that is related to the tertiary sector, and so the total primary energy consumption is this, and this is the specific primary energy consumption, that is related to the gross floor area coming from the EMM again, and then here are other parameters calculated for baseline situation. So the useful energy demand, and so on. Okay. And so this is done for the environmental KPIs, and for the economic KPIs, as I said before, the only KPI that is calculated for the baseline situation is the operative cost. Once the KPIs are calculated, you can go further and go to the step 3 calculation and set up. Okay, here you can first of all visualize all the already commented KPIs, baseline KPIs, and then you can select the planning criteria. Okay, so for example, let's select the reduction of primary energy consumption. We would like to okay, in the step 2, we are creating the future scenario. So starting from the data here calculated for the baseline scenario, we can realize how can we shape a future scenario according to defined planning criteria. Okay, so these numbers give us the idea of what is give us the quantification of what is our base scenario, the reference scenario. And so then accordingly we can select the planning criteria. So imagine that we want to reduce the primary energy consumption from the baseline to a future scenario. So we can add the criteria of the energy domain. And then the same, we would like to reduce the CO2 emissions. So we can add this criterion here. And then from the economic panel, we can select the operational cost reduction. So we can add this criteria. Then there is an algorithm developed by another partner, by Vito, that ranks from the worst to the better all the sources that you can select theoretically from your territory. Okay, so so in this case you can see that according to these 3 planning criteria, natural gas is the worst option, while other local sources like cold water body, excess heat, and biomass, for example, are better options. And so this gives you an idea on which type of source you could use to reach your target. And regarding talking about the target, here in the tab, visualization of KPIs and target values, again, not again, sorry, but all the KPIs listed before are filtered according to the selected planning criteria. In the sense that for each criterion there is a panel of KPIs, and so only by selecting one of them, only the KPIs related appears. Okay, so in this case you have the value for the primary energy consumption of the baseline and the specific energy consumption, and here you can set your target. You can set your target in terms of primary energy consumption of the future in in total. So you can say here that you want 90 megawatt hour. This is a typo. For example, this is not megawatt hour per square meter, but a megawatt hour per year. Okay, you can say 90, or you can say that the specific, so megawatt hour per square meter per year is not 0.90, but 19, sorry, 0.0 0.12, for example. Or you can say the variation in terms of percentage of primary energy consumption from the baseline is 10%, okay? And so on. And this is the target that will be verified after the calculation of the citizen. And then this you can do also for the other KPIs. Okay. So when you click on OK, you can go to the step 4, the last steps of the characterization of the scenarios, and here you can characterize the future scenario. So according to the year that you have specified in the DMM for the future scenario characterization, the calculation will be done. So if you have selected a 5-year further the basis scenario, here the number of years considered is of course 5. Okay, and the economical KPIs will be calculated accordingly. So in this case, the situation is that theoretically I have characterized building number 15 and building number 16, and so the nice thing is that the information of the baseline scenario are still present here, but the peak demand are related to the future scenario, so future numbers. Okay, but it is important to still have in mind which is the business scenario situation in terms of technology. And so I know that for the building number 15, the gas boiler, blah blah blah, and so on. What I have to do here is to remove the technology and then select another technology. So in this case, I will select the biomass boiler, select higher efficiency, and maybe select the same peak power. Here, let me put 100 and higher peak potential of 300 kilowatt, a fuel cost of 0.09, and the variable cost of 0. Then when I click on apply, I have to be sure to have highlighted the proper building. So when I click on apply now, biomass boiler, biomass forestry as source appears with all the information. And then I do the same for the number 16. No, but before I have to remove then select the building and then okay. These numbers are taken directly from the previous step. So the first time you will find them as you have input before, but if you want to change it, you can edit it. Then again, I will skip after. And then confirming the future scenario assessment, you can go to the last step, that is the district simulation model, the DSM. So the first tab that appears when you launch the simulation module is the summary of the KPIs in terms of KPIs from the baseline and KPIs that are going to be calculated for the future scenarios and the target that you have selected for one of the future one of the KPIs related to the future scenario. This is for the energy domain, for the environmental domain, and for the economic domain. Okay, so we are ready to launch the simulation, but before another aspect that I didn't comment is that you also, that is very important, to check the local source availability. I can come back in the baseline scenario assessment when I have calculated KPI. I also can have a look to the final energy consumption that is calculated per each source. So in this case, only natural gas, because only natural gas is selected. So from this list, I can see which is the final energy consumption per each source that is used, that is consumed. Okay, and this is important because for the local sources, I can check once I made the simulation for the future scenario if the local sources are available. So coming back to the simulation module, here I can of course select this filter regarding the final energy consumption. So crossing the fingers and push the simulation button, simulation should start.
Yes.
You switch off your microphone because you're pushing buttons very hardly.
I was in the way. To be honest with you, in the waiting of the simulation, I try to do something.
I understand. So yeah, we have some preliminary results, and so we are still, as Stefano said before, we are still checking if the results are displayed correctly, and if, also for some of them they are calculated correctly. But of course, here we are still in the fixing phase of the bugs, and yes, the idea, as you can see here, is to have the future scenario calculated in terms of KPI that we selected, and to check the results with respect to targets. So in this case, for example, we set the target of course, minus 10% of prime energy consumption, so a variation of 10%. Less, and here we have reached using this particular technology and this particular resource a minus 5.36%. And so the target is not reached, and so this number is in red. So to say to you that the target is not covered. In this case, I put 90 here, and this should be okay, but it is not because here there's another the same number because of yes the settings that I put. But okay, and this is the main result. So the possibility to simulate both scenarios and to verify some targets according to planning criteria and according to the outputs that comes out from simulation of given scenario. Regard, and then you can also check the final energy consumption of each source that you have included in your simulation for the future scenario and for the data. Here, that is still check. You should be able to verify if what comes out from your simulation in terms of final energy consumption of local sources that are deep geothermal, shallow geothermal, solar thermal, expertise, wastewater, and so on. If all the sources in terms of availability, and this is the number that is given from the supply master module, should be checked with the final energy consumption. And so, of course, if the final energy consumption that comes out from the simulation is more than what is available in terms of local sources selected, this would not be the case. This should be an error in your scenario, future scenario definition, and it will be shown to you an error message, a warning message, and this will allow you to come back to previous steps and to change something in the future scenario definition in terms of technology, in terms of efficiency, in terms of doses, and so on. Then the last feature of the PLANHEAT tool is the possibility to visualize some figures, some graphs related to the hourly simulation that are performed by the engine that is running, provided by University of Zagreb. That is the core of the simulation that are running and performing results that then are post-processed to calculate the KPIs as I shown. This engine, this algorithm, provide an optimization calculation based on the minimization of the operational cost of the technology that you have selected. So according to the demand that is going to be covered, and so coming from them, and according to the technology that you have selected to cover that particular demand, this algorithm makes an optimization in terms of operational cost, so related to fuel consumption and to operating and marketing cost. Yes, mainly that's it from my side.
Yes, I think that that's more or less it. So I'm going back to show my presentation. So I kindly ask you, Matteo, to interrupt the sharing. Thank you. So as you could see from Matteo's presentation, even for a quite simple test case as we did today. The procedure is quite long and time demanding. Obviously, today we showed it to you in a quite complete way because this is a webinar, so we have to present it to you in the best way possible, obviously. Actually, I think you cannot see the presentation. I think. Okay. Anyhow, okay. Now you have it. Just really the last slides that reminds to all of you to take a look of our e-learning platform, where in our e-learning platform you will see all the updated material. One relevant outcome that I would like to tell to everybody, both who is attending and also to who is going to follow us via the recorded webinar, is that all the training material, all the training modules have been updated, also with new screenshot coming from the final version of the integrated tool. I don't know if there are any question and answer to Matteo from the audience.
Sorry, Stefano, do you have the ball or not? I don't understand if you...
Sorry?
Stefano?
Sorry, Matteo? Yes, please.
Do you have the ball again or not? Because I cannot understand because I didn't find anymore the dialog window of Quick Meeting.
I'm now coming. I came back to the presentation. I'm now sure.
Okay. I can see.
So, so I don't know if there are any questions from the audience to Matteo for what concerns the showcase. Otherwise, as I said, I would like to thanks to all of you to attend this session, and not only this one, but all the other ones, because as I said, this is the first module 4 session. So we are with this session, for example, for what is concerned the PLANHEAT training for Southern cities, we completed the whole training campaign. We are probably going to have maybe some additional trainings, some additional webinars in the next months, where we hope also to show you some update in the tool development. But generically speaking, as I said, please, if you miss something, please visit our e-learning platform. We can see and we can find all webinars recorded, all training materials for all modules available and duly updated. I would like very to recommend this because we updated the slides, we updated the training module with the final tool version screenshots. And I would like also to remind to all of you that if you would like to use our tool, please keep please keep updated about the project, and please take a look of our website, of our social media, where we will inform everybody about the delivery on the project website, so the publication on the project website of the final version of the tool for your usage. So one more time, thank you again for your attention. Thank you again for having followed PLANHEAT project since the beginning. Keep you updated via our social media and with our project website. Try, if possible, to use the PLANHEAT tool as soon as possible. And thanks to all of you. Thank you very much, and have a nice weekend. Thanks, Matteo.
Can you hear me?
Yes, thank you very much for your support.
Okay. Thank you. Thank you, everybody. Bye.
Bye.